All right, so we have previously talked about vector addition, adding vectors to each other, but we also said there's a number of different operations that can be performed on vectors, and that includes multiplication. So in this case, we're specifically going to look at multiplying vectors by a scalar quantity. So scalar, remember, whereas a vector has direction and magnitude, a scalar quantity is basically just a number. So scalar, so that's going to be some number k. All right, so let's take a look. In our first example, we just have our standard regular vector chilling right here, and it's just labeled a. Now it's labeled 2a. So this means our k value here is equal to 2. That 2 looks terrible. That's slightly better. And what did we notice happened to the vector? If we look at the lines, they're still parallel, so the direction has not changed, but the length of the vector has changed. And we can see similarly down here, in our next example, k is equal to -3. And what's happened to our vector? Well, it's longer, so we've multiplied the magnitude by 3, so it's 3 times the length of our original vector. But also notice that the tail and the tip have switched positions. So the negative means that we flipped the direction, so we can't like rotate the direction, but we can flip it back and forth. So what do we notice in each case? Let's write it, what we just said. So in the case when k is a positive value, +2, it's same direction, but magnitude is doubled. Magnitude doubled, so 2x. And in this case, our magnitude is tripled. And the direction is reversed or opposite direction. So whether the k is positive or negative tells you if the direction is the same or reversed or opposite. Those are only two options. And the magnitude of the k value tells us how much we've scaled the vector by, how much longer, what number have we multiplied by. All right. So let's talk in general terms. Consider Ka, where k is a scalar and a is a non-zero vector. And I think I might need to type here. So if we have Ka, I'm not used to typing on the iPad. It's be a new experience. There we go. Come on. Just want to make a dash. All right. If we have, if k is greater than 0, k is greater than 0, and I'll fill in some of the blanks with writing in a moment rather than typing. Then Ka, so if k is greater than 0, then Ka is in if k is greater than Ka, then Ka is in the same direction as A with a magnitude of k times the magnitude of A. So I'm gonna put the rest in here with the pen. So if we have Ka, where k is greater than 0, then Ka is in the same direction as A with a magnitude of k times the magnitude of a. I'm not going to bother typing the other one. What is our other situation? If k is less than 0, then Ka is in the opposite direction of A with a magnitude of, we don't care if A is positive or K is positive or negative, so we use absolute value. Just care how big it is, with magnitude of absolute value of K, absolute value of A, or magnitude of A. All right, another definition. What does it mean if two vectors are collinear? All right, well, the two vectors u and v are collinear if and only if it is possible to find a non-zero scalar k such that vector u is equal to k times the vector v. When discussing vectors, the terms parallel and collinear are used interchangeably. Because remember, we can kind of move vectors around. We saw that when we added them up, we can, like, if as long as you don't change the length of the direction, we can slide the vector around into different places and nothing changes about it. So that's the same thing here. If I have two vectors that are parallel and I slide them so they're lying on top of each other, well, now they're collinear. They're still the same vector. They have the same length. They have the same direction. I can move them around. Nothing changes. So if they were parallel originally or they're on top of each other, they're collinear. Same thing. Same vectors. So just keep that in mind. Next up, as we continue to work with vectors, is creating unit vectors. That is, vectors that are only 1 unit long, so they have a magnitude of 1. How do I make a unit vector that is in the same direction as vector x? So we're going to have vector x and I want to find a unit vector. So same thing, but it only has a length of 1. It's hard to write a small 1 on here. So what do we know about the vector? Well, let's say our vector has a magnitude of 5. I'm going to make a quick adjustment to the pen here. Yeah, let's go with that. And I want the magnitude of x to be, or the magnitude of my unit vector to be only 1. What do I need to do? I need to make my vector smaller somehow. I need to scale it. So if I multiply by some k value that's greater than 1, the value is only going to get bigger. I want to make it smaller. So basically I'm dividing or multiplying by a fraction. So what would happen if our k value was 1 over 5? Let's find the length of our new vector. Basically, we're just going to divide by the magnitude of the whole vector. So we're going to do vector x divided by the magnitude of x, which we kind of already did here. K has to be 1 over 5. Where do we get that 5 value from? That's the magnitude of our original vector x, equals 1 over 5 times vector x. So basically, we're multiplying the vector by 1 over magnitude x, or dividing the vector by its magnitude. So let's write that in words. So how do I find a unit vector? How do I get a vector in the same direction, but with a magnitude of only 1? Multiply by, so a k value of 1 over magnitude of x. So we're multiplying that by our original vector, or multiplying by a fraction is the same as dividing. So divide by its magnitude. So our vector x divided by its own magnitude And this gives us our unit vector in the direction of x. Unit vector in direction of x. And what about in the opposite direction? What if we want a unit vector? So unit vector, length of 1, but in the opposite direction. Remember, if our k value is negative, then the direction flips. So we want the same thing, but we want it to be opposite. So in other words, original vector x, we divide by negative the magnitude of x, and that'll give us a vector with the opposite direction and a length of 1, so a unit vector. In our next section, we'll talk about subtracting vectors.